Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to the subject of Machine Design 1. We are right now learning about the design procedure for various keys. In today's session, we are going to look at the design of Kennedy key, which is more prominent when the transmission of power is concerned or efficient power transmission is concerned. So let us look at it. So friends, you can look at the screen. Let us start with the design of key aspects of this particular Kennedy key. So the failure is very important thing. So it is happening along AC. Let's look at how AC is prominent. Now this is how the key will be subjected to the torsion. There are two keys kept in pair and that's why they are called Kennedy keys. So this particular pair is nothing but your Kennedy key. So they are equal in size, that means their cross section is same. So the cross section is generally square and they are placed in such a manner that their diagonals will fall at an angle 45 degree with the diameter in both the ways. So if I name this particular diameter is AC, when the force is going to act on this, in one manner it is going to act empty and in another manner the compression is going to act on this particular key, basically these keys. So in that case AC will be the diagonal or the layer at the diagonal which will be prominently undergoing the failure, and that's why we are considering AC for the failure, because that is the more prominent one for the failure. So there are two ways again, that will fail in shear or that will fail in compression. When it comes to shear, it is very clear that along the diagonal the length is going to be at 45 degree. That's why the root 2 component comes out there. So this is what the area which is going to get the shear thing, and that's why we have to consider this. Now converting it to the torsion or the torque, which is very simple, force into the area or force into the length at which it is going to be subjected, and that's why this formula is converted to this one. Also we are going to consider the compression. In that case this formula is converted to this manner, right, considering again force thing, and that's a part of derivation. So formula 1 and 2 are prominently used for this particular adjustment. So this is how the cross section will be, this is what the layer which is going to fail, and this is how the forces which are going to act on this particular key. Now forces are not acting directly on the surface, they are acting in inclined manner just because the location of that particular key, and hence this is how the forces will act on them and they will try to form a couple, and to take care of that couple we are going to consider the shear strength. Let us now look at the problem statement. It says a shaft of diameter 40 transmit 35 kilowatt at 300 rpm. It carries a key of given cross section. Material of the key is specified and we have to use the factor of safety 3. We have to find out the key or we have to select the key for this particular. So let us quickly write down about the given data. The very first data that we have been given is diameter D of the shaft, that is 40 millimeter. The power that the shaft is supposed to transmit, it is 35 kilowatt. The next thing we have been given is the RPM. We have been given the cross section of the key also. So we'll say B by B, or in some manner we can say B by H also. Since they are same, it's 10 by 10 millimeter. The next thing we have been given are the material properties for the given keys. They have also specified that both the properties are same as far as the torsion, tension or compression is concerned. So the value we have been given is 380 Newton per millimeter square. We have been given factor of safety also. Now this is a standard practice to use factor of safety somewhere around 3 or 4 as far as the keys are concerned, because of their location, because of their importance and the material that we use for them. So this is what the data we have with us. Let us proceed this data. The very first thing is the torque that we need to find out. We have been given the formula which is very famous again, power in kilowatt into 60 divided by this, and particular, let us substitute the values. The value we have been given is 35 As we solve this particular expression, the value we get is somewhere around 1 thing you need to understand that this particular unit comes out when we take kilowatt power here. Gives me the torque unit to be Newton millimeter. So with this particular MT, let us go for the further calculation. The further calculation is about the safety value. So let us quickly look at them. And therefore, the allowable value in compression will become, let's substitute the value of factor of safety 3. The value comes out to be we know that it is a industrial steel, and that's why we need to consider tau value exactly half its value in compression. So it becomes sigma c divided by 2. Let's substitute the value. The value comes out to be so this was about the safety values. Let's move ahead with the calculation. The calculation is based on the failure theories. Now again we know that there are two ways it can fail. The first one is shear due to torque, and the second one is compression, or you can call it crushing also. Let's consider them one by one. Let us start with the first one where shear comes to the picture. We already know this is the formulation for this particular key. So let's substitute the values. Let us reverse this formula so as to make it we have the values. Let's substitute them. Now we know that D and B in this case is same. As we move upon with the calculation stuff, we get the value of length somewhere equal to 26.95 millimeter. So this is the value of length which we have obtained with the first failure criteria. Let us move to the second criteria. Now second criteria is about crushing. This is the standard formula. After substituting the values properly, we will get, let's substitute the individual values. As we solve this expression, we will get the value of length somewhere equal to 31.10 Newton per. Extremely sorry, the unit is millimeter. So as we solve this expression properly, we'll get this answer somewhere around 31.10 millimeter. Now there we come across two different lengths. Let us compare them. Now for the final selection of key, we again know that in this case, length is not only inversely proportional with the shear stress value, but also the length is inversely proportional with the compression stress. So in that case, more the length, safer the value it is going to be, and therefore let's consider the higher value, which is somewhere around 31 point. Let us go for the standard value, and therefore the length of the key should be at least 32 millimeter. Which is a safe design. So friends, there we conclude with this problem where we have found out the length using shear criteria as well as the compression criteria, and we have found out the larger value is safe, and that's why this length of this particular given problem should be at least 32 millimeter so as to satisfy these conditions. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda. Thank you.